Okay, today we're going to look at the different ways that we can represent the outcome of an event happening. So there's two different things that we're going to look at. One of them is a tree diagram and the other one is a table or an array, which is another word for a table. Now the outcomes that we get, so when an event happens and we list the outcomes, it's got a special name which is called the sample space. So the sample space is the word that we use for the list of outcomes that we get when we conduct an experiment. These are important vocab that we need to take note of. Another one is an array or a table. So basically the simple word is table, but mathematically we say that it's called an array. Now when we're listing outcomes, it's very important that we are consistent in terms of what order that we are getting the outcomes. So for example, if we pick a book, or if we conduct an experiment of picking a book first and then a pen, when we list the outcomes have to be in that order of book and then pen. When we look at some examples, then you'll realize what we're talking about. Another important thing is there are two different types of experiments. One where, so there's a one-step and two-step or multi-step. Now, one-step is basically, an example is like you flip the coin once or roll the die once. Two-step is where you do the same event more than once or you use more than one equipment. An example is like flipping the coin twice. So there's the first experiment was when you flip the coin once, and the second experiment is when you flip the coin the second time. Or another way is you flip two coins. So therefore you get two sets of outcomes. But what we're going to look at is how we combine those outcomes into one tree diagram and one table or an array. So therefore, because of that, then different scenarios come. One is where you replace. So for example, if you're picking counters out of a bag, you pick a counter, check the color, put it back, and then pick a counter again. So we've done it twice. It's two-step, but we have replaced it. So that's with replacement, which means that your sample space doesn't change, or the probability of your outcomes don't change because you've got the same amount of items still in the bag. Another scenario is where you pick a counter, check the color, and leave it outside the bag. So you don't put it back in the bag. And therefore, the total number of counters that you have in your bag changes, which changes the probability. Now, if you think back to right at the beginning when we started doing probability, you need to remember how the probability of an outcome is calculated, which depends on the number of times the outcome happens divided by the total number of outcomes. So we're going to look at first a sample space by using a table, and then we're going to look at tree diagrams. Okay, so let's look at an example. First example, two coins are flipped together. Draw a table to show the sample space. Find the probability of getting a heads and a tail. And C, find the probability that you get at least one head. So the first thing that we'd like to do is to draw a table. So let's do a table. Okay, so I'm just going to maybe draw a table over here. Okay, because two coins are flipped, so we need to show that we have got, so this can be for coin 1, and that over here can be for coin 2, or either way, it doesn't matter. But what are the outcomes on a coin? Heads and tails. That's for coin 1. Same outcomes, heads and tails. That's for coin 2. Now, to list the outcomes, so when we list the outcomes, we just basically write down what we can get. So this is our sample space. The way we do it is we write them in a pair of brackets. So in a pair of brackets, so we can get a head on your first coin and a head on your second coin. I'm actually going to change the order and make that coin 2 and make this coin 1, so then it becomes easier to follow. Okay, so heads on the first coin, heads on the second coin gives us heads and heads. Heads on the first coin, tails on the second coin gives us heads and tails. See how I've written that in order? First coin, second coin, first coin, second coin. Now, you can also get a tails on your first coin and a heads on your second coin, or a tails on your first coin and a tails on your second coin. Okay, sometimes these are written with a comma as well, and that's okay. So therefore, the sample space that we get, and let's write that down, our sample space is basically all of these outcomes. Heads, 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 tails, tails, heads, tails, tails. That's our sample space. All right, now let's look at our probability. Find the probability of getting a heads and a tail. So you have to find the probability of a heads and a tail. Now, it doesn't say which order. So if we go back and look for a heads and a tail, we can see that we can get a heads and a tail there, and also a heads and a tail there. So which is how many? Yep, there's 2. So that is equal to 2 out of a total of 1, 2, 3, 4 outcomes. And if you simplify that, that's half. You can also write as 0.5, either or 50%. There's 3 ways that you can represent probability. Okay, now let's look at C. Probability that at least one is head. At least one. So if you look at the probability that there's at least one head, so this was for that one, and let's do the second one. At least one head means that you have one head only. So that is that one. There's one head. There's one head. There's another head. So 1, 2, 3. So if you write this down, and that is the color. So the probability, I'm going to, if you notice, I've used 2 ways of representing probability. One is just writing as P, or P and a lowercase r. Both of them are correct. Okay, so at least one head is equal to 3 out of a total of 4. So that's it. Okay, now let's move on and do the second example. This is where we do not replace the counter. Okay, so a bag has 3 green counters, 4 blue counters, and 5 red counters. 2 counters are chosen at a time without replacement. So that means we are not replacing it. Okay. Find the probability of getting a red and a green in that order, the probability of a red and a red, and the probability that at least one counter is blue. Okay, so the first thing that we can do is make a table. So let's do our table with all our outcomes. Okay, so in the first pick, you can either get green, 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 blue, 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 or red, 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 red. Now, that will become a little bit messy to do it in this small space. So what we'll do is we'll do this together in class, and then we'll do it on the board, and then we'll come back and do these answers. All right, moving on. The second way of representing your sample space is by using tree diagrams. So if you have a look, now this is a 1, 2, 3-step experiment, which means you are flipping the coin 3 times. Okay, and then the second one is without replacement, 1, 2-step experiment, but it's without replacing. So you're selecting the letters, but you're not replacing them, you're not putting them back. All right, now let's look at some examples. The important thing to note over here in a tree diagram is that when you draw a tree diagram, you write the outcomes at the end. These are called the branches. On the branches, we write the probabilities, which we'll do when we do an example. Once we've finished writing the outcomes at the end, right at the end, you write down the sample space, which is written like that in the order. So there was a head, 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 head. There was a tail, head, head, tail, head, head. So in that order, that's how you write the outcomes. All right. And to work out what each of these probabilities are, whatever the probability there and there and there is, you multiply them all together. And we'll do that when we do this example. Okay, so same example, just a different way of representing. 2 coins are flipped together, draw a tree diagram now, and then find the probabilities. Let's see if we get the same probability or not. So let's draw the tree diagram first. Because it says 2 coins, so we get a head and a tail. That's first coin. Second coin, a tail and a head. Oh, look, I'm just going to put it in the same order. Sorry about that. A head and a tail, or a head and a tail. Then let's write down the outcomes. So head and head, head and tail, tail and head, tail and tail. Okay, that's our sample space. Or outcomes. 2 names. Another thing we do is we write down in the branches what the probability is. So if you flip a coin, what's the probability of getting a head? There's only 1 head out of a total of 2 outcomes, so therefore our probability is half, and the same for tails. Because we haven't changed anything, the probability doesn't change either. Okay, now let's do A. Find the probability of getting a heads and a tail. So a heads and a tail, a heads and a tail. The first thing is the probability of getting a heads and a tail. There are 2 of them. One is probability of getting a heads and a tail. The other one is probability of getting a tail and a heads. Now remember what I said earlier, when you have to find the probability of each outcome, you actually go back to your tree diagram and multiply your probabilities together. So the probability of getting a heads and a tail is basically heads and a tail is half times by half. Okay, same with the heads, tails and heads, half times half, which is equal to 1/4 plus 1/4, which is equal to 2/4, which is equal to a half. Make sense? Okay, now C. Probability of at least 1 head. At least 1 head is, again, 1, 2, 3, at least 1 head. Okay, so same thing. So the probability of at least 1 head is equal to probability of HH plus probability of HD plus probability of TH. Now we can work out that probability of HH would also be half times half, plus half times half, plus half times half, which gives us 1/4, 2/4, and another quarter, a total of 3/4. Now let's go back and see, do they match our answers up here? Yes, they do, half and 3/4. So no matter which method you use, you will still get the same answer. What we'll do is, again, with the second example, we'll do this together in class, and we'll do the table, and we'll also do the tree diagram at the same time.